Hi, here's section 9.8, problem number 19, page 504 in our book. And here we have a system of two quadratics. We want to find the points of intersection. And so first of all, I'm just looking at this and thinking to myself, what do I have here? What is this? And so right away, I think I'm going to go ahead and look at this and say, you know, hey, my first equation, quadratic relation here, equation, is a hyperbola, right? Because the signs are different. And so I know this is a hyperbola. So I have something like this, a hyperbola, and then I look at my second equation right here, and that's a linear equation, that's a line. All right, so a line going through the hyperbola, it could be something like this, where I have 2 points of intersection, and as a matter of fact, it is, because I'm going to just show you, I went to Wolfram Alpha, I think I have it down here somewhere. Yeah, you can see right there. Here is the plot of 16x squared minus 3y squared equals negative 11 and 8x minus y equals negative 11. And look right here. Look, if I hover over that point, that's one of the points of intersection. Negative 2, negative 5, and there is the other point of intersection, negative 1, 3. So can you just give me those 2 points on the test? Absolutely not. You may not. You have to actually solve it. But we know what the solution is going to be, right? There it was, right there. All right, so the way I'm going to solve this, I'm going to pick another color. I'm going to work with black. I don't know. I just haven't done black very much. I think I'll take the second equation here because it looks the easiest, the linear one, and I'll solve for y. So in this second equation here, I'm going to get the opposite of y is going to equal negative 11 minus 8x. So therefore, y has to equal 11 plus 8x, just multiplying everything by negative 1, right? Or y has to equal 8x plus 11, the commutative property. There we go. So my second equation, the y is equal to 8x plus 11. Okay, now I'm going to erase that because I don't have a lot of room here. So we know that y is 8x plus 11. So I'm going to substitute that in for y in my first equation. So my first equation is 16x squared minus 3 times y. But remember from the second equation, y is 8x plus 11, right? Squared equals negative 11. Now I think we're going to get some monster numbers here, but I think it'll be okay. Because watch, I think everything's going to just reduce nicely. So 16x squared minus 3 times 8x plus 11, what is that going to be? 64x squared plus 88x, 88x. What is that? 88 and 88. Is that 170? I can't remember. 88 times 2, 176. That's right. 176x plus 121. That's going to equal negative 11. Now I got to multiply 3 by everything. And I totally forgot what all those are too. 3 times 64, and then I'm going to take 3 times 176, and then I'm going to take 3 times 121. All right, I got all my numbers right here. All right, so this is going to become 16x squared minus 192, right? X squared minus 528x. Right, just distributing 3, right, to all 3 terms. And then negative 3 times 121 is negative 363 equals negative 11, right, equals something a little bit better. All right, now let's see. I'm going to take 16x squared minus 192. So let's do that right here. Let's see, 16 minus 192, because those are like terms, right? And so here I've got negative 176x squared minus 528x. And now look here, minus 363 plus 11. Let me bring that over to the other side, okay? So negative 363 plus 11. And I get 352. So negative 352 equals 0. And now I'm going to divide everything by negative 176. Okay, and this is where, watch, x squared plus 2x, I think, is that right? No, plus 3x right there, excuse me. 528 divided by 176 is going to be 3x. just dividing a negative 176 out of all 3 terms. And then this is going to be plus 2 equals 0. So look at that. And then doesn't that factor beautifully? Yes, it does. Because look at that. Don't I get x times x is x squared, 3x is my middle, and 2, yep. And so we can see here x equals negative 1 or x equals negative 2. Now, I believe that works for us. Let's try it. So first we'll let x equal negative 1. I'm just going to substitute in this second equation right here. Oh, I think I'll pick a different color because, no, I thought it was that color. All right, so if x equals negative 1, I'm going to get 8 times negative 1, right, minus y equals negative 11. Why put it in the first when I can the second is so much easier, right? Negative 8 minus y equals negative 11. So let's see, we'll add 8 to both sides. The opposite of y equals negative 11 plus 8. What would that be? 3? Negative 3. And so y equals 3. All right, so I'm telling you, one of the points of intersection is going to be the point negative 1, 3. I hope. I don't remember seeing that. I don't know. We'll go look again at Wolfram alpha. And then over here, if x equals negative 2, you're going to get 8 times negative 2 minus y equals negative 11. 16 minus y equals negative 11. Add 16 to both sides. What do I get here? The opposite of y was 5? Yeah, yeah. I kind of remember this point. So y equals negative 5. All right, so the solution set then, therefore the solution set will be the ordered pair negative 1, 3, and it will be the ordered pair, let's see, when x is negative 2, y is negative 5. And let's look back at Wolfram alpha one more time. Is that what we got over there, Wolfram alpha? Is that it? Look at that point right there. Let's see, it's hard. Negative 1, 3. Hot dog. Look at that. Look at that. What was that? 2, 5. Negative 2, negative 5. Isn't that, those are our 2 points of intersection, right? Negative 2, negative 5, and negative 1, 3. Done. Bam. All right. Talk to you later.